Okay, we just finished the background information on what you quote-unquote need to know to keep going on this topic. That was a good one. I'm glad we did that. In this first section, we're going to be taking a look at some of the basic skills of navigating around the Cartesian plane. We're not ready for lines of equations of lines yet, but we are ready to start looking at kind of significant spaces on the Cartesian plane. What I mean by that is the following. First one is the midpoint formula. Assuming that you're given 2 points, A and B, somewhere on the Cartesian plane, how do you find the point that's plunk in the middle of them? Exactly on the straight line that would connect them and precisely halfway. Well, there's a formula for that, and luckily it's in our formula kit, and it's this here. That formula might look a little bit intimidating, but basically what it says is you take the two x values and you add them and divide by 2. Now you may think of that as finding the mean of those two values. It's a small mean because it's only a sample of 2 points. And then, of course, you've got the means of the y values right over here. And so that's a new point. So this is another way that some people refer to the midpoint as the mean point. Meaning, pun intended, the mean of the x's and the means of the y's, forming their own new point. How do you use it? Well, let's see. Here we got 2 points, A and B. We're trying to find, they end at the ends of a diameter of a circle. You want to find the coordinates of the center. Well, I think most of us remember that the center of a circle lies at the middle of the circle. So it's halfway along its diameter. So I'm going to take a little picture of that to make sure I'm comfortable with it. And if I've got, let's see, the point -3, 5. That's over here. You can see it flashing at -3, 5. And then you got the point 0, 7, which is now flashing into the top middle of the screen there. And so there's the circle that they must have been referring to. So where is its center? You could try and visually, optically pin it down, but not likely with a tremendous amount of precision. More effective and more precise would be to use a formula to work that out. So what do we have here? This is rolling through the same thing again here. We've got -3, 5 over here. We've got 0, 7 here. So somewhere halfway is the midpoint or the center of the circle. So what I'm going to do is use the formula and say, well, basically I want the mean of the x values and I want the mean of the y values. And that gives me -1.5 and 6. And so you can see that that's a very convincing location for the middle of the circle. And we've used the midpoint formula to find it. And we didn't have anything to do with the circle itself. As the IB often does, to make sure students really understand what's going on, they take some of the information from a conventional wording of the question away, and they ask you, and they give you answers, and you're going to work backwards. So what they've said here is that we know that the midpoint of A and B is the coordinates -3 and 1.5. But what they didn't tell us was one of its x values for part A and part B's y value. So how are we going to work that out? Well, it turns out you can make this into a little equation since you know what the answer is going to be. And so what I'm going to do is I'm going to say I'm going to let this be x1, I'm going to let this be x2, and I'm going to put it into the midpoint formula, set the answer equal to 3, and say solve for x. And it does. And then the same is true with y. The values are y and 1.5. It doesn't matter what order you put them in. Oh, I think I made it. No, sorry, y and 5. I got them back over here. And the answer is 1.5. Solve for y, and the answer is -2. So I know that the point A must have been -5, and part B must have been -1, -2. And notice that I did not need a Cartesian plane, a visualization to solve it at all. I can use algebra to know what's going on sort of beyond the reach of where I can see. Now, this is where things are going to get a little bit more serious. We're going to take our principles of Cartesian geometry with x and y, and we're going to bring into a new variable called z, and we're now in Cartesian 3 space. So it's no longer the xy plane, it's now xyz space, and those coordinates that you're used to, having 2 numbers, has grown to be 3, and we've got an additional axis. Well, let's take a look here. It says a rock climber is standing at a certain place whose coordinates are 60 in the x direction, 80 in the y direction, and 0 in the z direction. We go along that pathway, and then nothing up or down. And so that leaves us there. but he's going to be climbing, or sorry, it's another rock climber's over here up the z-axis, 0 in the x direction, 0 in the y, and 400 in the z. So how many meters above the horizontal plane would the midpoint be? So they got M here, which is halfway the journey between the two climbers. How high is it? Let's take a look at that. I've gone to one of my favorite 3D sites. It's called Geogebra, and I can show you that in class. It's a lot of fun. And I've actually labeled these points here, there, there, and there. And if I can put a little rotation on this thing with this animation, you get a better sense of it. Sometimes a two-dimensional diagram isn't as handy for visualizing, but since we've got the technology, should we probably use it here? Now I'll give this a little spin. You can see the climber high up, point C. Well, they called it S. I called mine C. That was a bit regrettable. Anyway, I'll continue with that, and I'm going to try and find out where to go. I'm going to insert point R on this diagram. Get it nicely rotated. Oh, I called it M by accident, but never mind. That's this one over here. And now I'm going to make a line connecting them. There it is there. And I'm looking for the point that's halfway up that line. Well, I just used the formula like we had before, but I extend it to include a third coordinate. And that gives us, now you see this extra bit added on here. You use that to figure it out. Here's the coordinates for one and the other. And if you put it into this formula, you'll know the midpoint is 30, 40, and 200. If I go back to Geogebra, you could go ahead and see where that would be. I'd like to hit pause and try this one for yourself, and I'll join you in a moment. Okay, I'm assuming you've given this a try, perhaps on Geogebra, probably just on with algebra on paper. You've got coordinates here, which are three-dimensional coordinates, and I need to get a look at them. I think I'm going to go ahead and actually just show you them because it's easier when you're starting out rather than just dealing with the algebra. And you can see the points A, B, C, and O laying down there according to the coordinates that were given. And I'm going to add some more to it now. There they are. Now let's see. I'm putting in the other coordinates that were above it at a height of 2, and you can see them being slowly added to it. And we're delineating out what we call, you may recall from chapter 2, called a cuboid. It's like a box. It's got rectangular faces, and there's all these dots, 8 dots, delineating them. So what they wanted to know was sketch it and then find the midpoint of the diagonal between A, here, A, and C1. Well, there's A, and C1 exists above C, which is going to be here, but the Z coordinate is going to be 2 because it's higher up. Anyway, you just use the formula once you have the coordinates delineated, and then you can find out the midpoint, which is right there. Explain whether or not you'd expect AC1 and A1 to see that same midpoint. So basically, if you were to make a point over here and join them, or if you were to make a point here and join them, would they cross each other? And I think it's pretty visually obvious that they would cross. Okay, if you need help with 3D graphing on your laptop using GeoGebra, ask for my help. Usually these questions come with a diagram pre-made, and you just need to use the formula for finding the midpoints. You can see there's some 3D ones coming up here. Not a lot of questions. It's just getting used to finding out the midpoint and using some Pythagoras theorem. So we're in 4A, and that's right here. Just a couple questions to do. I invite you to give them a try. All right, good luck.